amplitude here. So none. Okay, this is a very important fact that we have to know. You see, period is just pi. Yeah? What was it for sine and cosine? For what was my period for a regular sine curve and a regular cosine curve? Flip back over. Look at your notes. Flip back your notes. Just the period. You gotta look back in your notes. I'm talking about just sine. When we graphed y equals sine of x, what was my period of one complete sine curve? Or cosine. Either one is fine. I went to 0 all the way to where? In one complete sine curve. Yep, 2 pi. This one, I'm going all the way to pi. I'm going a distance of pi. So for the period formula, we change it to pi over absolute value of b for tangent and, spoiler, cotangent. So when we're graphing tangent and cotangent, that's the only time when we change the period formula to pi over b, not 2 pi over b anymore. Tangent and cotangent. Where? Change it. You change it. Change the formula to this. So this would be p equals pi divided by absolute value of b for tangent and cotangent. I'm starting to write cursive. I need a fatter one. Okay, at this point, we're talking about transformations of tangent. So transformations. Of my function, and it is y. Oh, that went big. Y equals a of tangent, and then inside is our b value. B there. Okay, let's look at Desmos for a second. Yeah, go ahead, Kian. Oh, I never showed that to the last class. Well, oh, that's pre-calc. Don't look at that. Oh, the wrong thing. There we go. Okay. This is regular old tangent right now. Okay, it keeps going on forever and ever. Okay. It just keeps going on forever and ever with our asymptotes. Okay, if I change A, it's going to slightly shift over, and then it's kind of going in straight lines, almost linear at that point. And we're going over in the other direction there. It's flipping over an axis. It can actually flip over either one at this point. And flip. Boom. Right over, we're going to say the x-axis. And if I go to 1, what do you think is going to happen if I change B? Compress horizontally or vertically? Watch what happens. Oops. So it's shifting. It's compressing. We're getting really, 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 really thin. And then we're going to stretch them out. And then we flip to the negatives, so then it goes the same thing as before. But when we're doing fractions, they're getting more spread apart. This, we're getting closer and closer together as we are increasing the value of b. Cool. Okay. A. We are doing vertical. Okay. You can use unit circle for what? I mean, you can put it on a note card. Yeah. The unit circle is going to be on your test. So definitely going to want it. Okay, vertical stretch. When a is greater than 1, not 0, 1. Apparently I want to keep writing 0. Okay. B, we have a horizontal stretch. When a is greater than 1. And for both of them, if negative b, we flip over the x-axis. And if we have a negative a, we also flip over the x-axis. And that is the end of tangent. Yes, cotangent is next. Yeah, I think there's one over there. Okay, our next function is cotangent. So y equals cotangent of x. Cotangent can also be written as what? Yes, because it's 1 over tangent of x. So opposite of tangent is cosine of x over sine of x. Because tangent would just be sine over cosine. Now it's cosine over sine. So same thing before. We need to find the vertical asymptotes. Definitely, if I want to find vertical asymptotes, I have to set something equal to 0. Is it my numerator or my denominator? Up here, we set cosine equal to 0, right? Yeah, because it was in a denominator. So we want to set now sine equal to 0. So sine of x equals 0. So when on our unit circle is sine or y values going to equal 0. So unit circle out. Kian, do you still have my unit circle? Look back. You're right, but look back. There's more than just 0. 2 pi? Okay, that's also true. 2 pi. What else? Got to unit circle. Also, heads up. Don't forget about the quiz. Unit circle. For my tablet.
Really?
Yes. I mean, wait, do it today. You can do it tomorrow.
What? Wait.
I don't know when we start. Well, let's do it before the end of the day on Friday. You still got 2 days. What the? When can you circle?
No way there's a way to memorize it.
Yes, there is.
Too many numbers.
It's gonna be easy. All you have to do is count to 1, 2, 3, and you get all your points.
Well, why do some of them skip by 2 instead of 1?
They were simplified.
Mm-hmm. They were simplified. What? Is it mine?
Oh wait, this is yours. I don't know why.
I was like, mine's in color.
This one's definitely.
Okay. Let's look on our unit circles. Unit circle. Yell. I want sine is 0. So that's when y is 0. So when do I have y coordinates of 0? I should give you yours back.
I need another unit circle, I'll be honest. I have no clue.
You can borrow mine if you want.
Can I just take a picture of it actually?
Yeah.
I can get a fresh one and then I'll fill it out.
Yeah, it's fine. Okay, yell. At 0, where else? Yep, on pi. Where else? 2 pi. Is that what you mean? At pi over 2, I'm at, what's my y value at pi over 2? 1. exactly. So it's not 0. But I can still keep going, right? Yeah. 2 pi over 2?
8 pi. Wait.
3 pi over 2, it's negative 1.
What's the point of doing that? Like, why are we naming that?
Naming what?
We're like
Graphing them?
0 pi, 2 pi, 3 pi.
Because these are vertical asymptotes. So finding
Is that the formula for
vertical asymptotes. What? This is cotangent, yes. Cotangent is the reciprocal of tangent, which is then also sine over cosine is tangent. You flip it, then we have cosine over sine. So tangent is sine over cosine. So if we want the reciprocal of that, we just flip it over. We have cosine over sine. Yeah. No, this is cotangent. That's why we have it, yeah. Okay. I can still go in negative direction. So I still have negative pi and negative 2 pi. And we go on forever in both directions. Okay. Let's put down these asymptotes. There we go. Okay. I will call this guy negative pi. Over here will be negative 2 pi. Over here, this is 0. This is pi. And this is 2 pi. Okay, at all those points, I have a vertical asymptote. Wenzel, can I ever cross a vertical asymptote? No, I can never cross it. I can get really, really, really close to it, but I can never ever cross it.
Why do we have 2 of them?
We're gonna have there's infinitely many of these. Yeah. Because just like tangent, negative 2 pi. But it keeps going on forever. You know how, like, here, tangent goes on forever and ever and ever? Like, if I keep scooching out. So wait, this is tangent.
How far can you go?
Oh. To, like, infinite. And then it just becomes a black hole of this. So I'm trying to zoom in now. And I'm just getting closer. So it just goes on forever, infinitely. What's up, Jade? Are you talking about tangent?
Yeah.
Because we're only talking about one cycle of tangent. Yeah. So we're only talking about one cycle. Okay. Let's do cotangent. So here are my values. We have x, and try to find cotangent of x. Now I have some asymptotes. I want to find all the values in between these asymptotes here. So I start at 0, and I have to go all the way to pi. Kian, what's in the middle of 0 and pi? In radians. Jade. Good. He can do it. Look at a unit circle. I'm at 0. Pi is over here. What's in the middle? Yeah. In between 0 and pi.
2 pi. No, that's.
So I'm at 0 degrees and 180 degrees. What's in between those in degrees? Pi is at 180 degrees, Kian. 180, yep, right there. So what's in between those two? Okay, look here. You're at 0, you're at pi. It's a straight line. I just can't move my fingers. If I go perfectly up, where am I at? Yep, which is what in pi? Yep, pi halves. Perfect. Okay, in the middle of 0 and pi halves is pi fourths. And the next pi fourth is 5 pi fourths. There. Okay. Because if I look, I was looking here, and here, and what is here and here. And exactly in the middle of that is, oh, it's 3 pi. Thank you. It should be 3 pi-4. I don't know why I have 5 pi-4. It is 3 pi-4. Okay. Where?
I'm just confused. Where we're getting these numbers from and how we're getting
Okay.
where we're starting.
So I always start at 0. Okay. I had asymptotes from 0 to pi. I got those because I took my denominator sign, and I was like, oh, where is sine 0? So then I went to this guy. I was like, okay, sine is my y values. So where is y 0? So like here, here I have 1 and I'm 0. So
What's x 0? Oh,
Yeah.
x 0.
where is y 0? So this is x and this is y.
I thought this was x.
I'm looking at it upside down, that's why. This is x, this is y. I'm looking at it upside down, that's why.
So
X and y. This is x, this is y.
Can I take this today?
Yeah, what? Yeah.
Figure it out.
So x and y is not 0 here. X and y is 0 here. So that becomes an asymptote. Because it's in the denominator. So whenever the denominator is 0, we have an asymptote. And then I have another asymptote here because my y is 0. Yeah. So now I'm just in the middle of 0 and pi. And I just want to get points in between these two. So I'm just like, okay, what radians are in between 0 and pi? So I really could have picked anything from here to here. I'm just picking the easy ones. This one's easy, this one's easy, and this one's easy. Yeah. So these are my easy ones right now. So if I'm at 0, I'm at an asymptote. So I'm at 0. In my unit circle, what is sine at 0? Yep, 0. And what is cosine there? What? 1, right? What is 1 divided by 0?
Oh, okay.
Undefined. Yep.
Why is it one?
Undefined.
Why is it 1, 0?
Because I'm putting cosine over sine. So if I'm on the unit circle, I don't have one of these. If I'm at a unit circle, I'm going to do cosine over sine.
Is that every time we have a cotangent?
Yeah, cotangent equals cosine over sine. Kian, did you watch the video on 7.3 that talked about reciprocal functions? Okay. Watch it. Watch it. It goes over a little bit more of this. Okay. Want to do the next one, Beatrice? Okay. Pi-4. So look at pi-4 on your picture. On your picture, units ago. Okay. What is cosine at pi-4? So what is the x value at pi-4? Wait, Jade, not you. You can do the next one, I promise. Yep, so I rad 2 over 2. And then what is sine at that point? So still looking at the coordinate. Yeah, rad 2 over 2. Okay, rad 2 over 2 over rad 2 over 2. That's the same thing, right? Over each other. So what is the same thing divided by the same thing going to equal? 1. Perfect. So we have 1. Okay, Jade. Pi halves. Yours next. At pi halves on my unit circle, what is cosine? Yep, 0. What is sine? 1. So what is 0 divided by 1? 0. Great. Okay. Declan. I'm at 3 pi-4 on my unit circle. What is cosine at 3 pi-4? So look at my coordinate. Yep. Is it positive or is it negative? Yep. Negative square root of 2 over... I'm going to scooch down for a second.
Over.
Yep. Why is it square root of 2 over 2?
Because it equals 1.
because it's sine at that point. Yep, and then if I divide these two together, I get what? Negative 1. Yep. Okay. Yeah, last one is for you. Okay, I'm at pi. On my unit circle. Okay, negative 1 is cosine. What is sine there? 0. What is negative 1 divided by 0? What is it? If I can't divide anything ever by 0. So it's going to be, yeah. You got it. Undefined here. Good. Do we have any questions about how we got any points? Wenzel, are you awake? Okay. Do you have any, what? You on blank one? Or, yeah, okay. Okay. Wenzel, do you have any questions about how we got any of those points? What is secant? You know what secant is? Okay, let's graph this guy. Okay, it has a height, the max height here is 1. The lowest one is negative 1. Okay, at 0, we are undefined, so I can't plot any points. At pi fourths, so this can be like pi halves. So pi fourths is about right there. I'm at positive 1. If I'm at pi halves, my y value is 0. So I'm right there at 0 for my y values. My next one is 3 pi fourths, so a little bit less than pi. So I'm right here on my x. Then I have to go down negative 1. So those are my 3 points right there. And the last one is undefined. I can't plot a point. Okay. Next thing I have to do is I have to connect all of these, going from the top all the way to the bottom. Now I can't pass the photoglass note, so I can hug it. Go down, go down. Oh, that was awful. Let me try that again. Okay, going down, going down. Ooh. I'm curving and I'm going down like so. That is my graph of cotangent. Jade, do you have any questions about how we graphed it? Okay, I can pick that thing up and I can do it so many more times, forever and ever. Graph it down here and go like that, down below. This is still pi over here though. The period of 1 is just pi, so I can go in the negative direction too, like so. All I did was kind of move tangent over and then I flipped it. That's the only difference between this guy and that guy. All I did was flip it over and move it over 90 degrees. So my period here is just pi. Lucy, what's my domain? Where did I start my graph at? Yeah, 0. Oh, it shouldn't be brackets. I should do parentheses. 0. And where did I stop? Because it was an asymptote. Where did so it was undefined here. Where did I hit my next undefined? Yeah, pi. So I went from 0 to pi. Then there was the asymptote. I can't go anymore. Then what was my range of this function? So my y values. Wenzel, what were my y values? What was it? Yep, all real. Sorry, I just didn't hear you. So I'm going positive forever and negative down, 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 down forever. This is just pi. Domain is 0 to pi. So, like, pi. 0 pi. 0 comma pi. Yeah. Okay, that is cotangent. We're almost done. Any questions about cotangent? No? Yep. Next one will be secant. I'm going to scooch over. And we got our next one. So, y equals secant of x. Secant is the reciprocal of what function? Or what? Is it reciprocal? It means I'm just flipping it over. I'm like frequency is the reciprocal of period because frequency is 1 over p. I'm just putting in the denominator, putting a 1 up top. P is period. Yes, except for tangent and cotangent. No, b is what number is affecting our argument inside of the parentheses. Frequency is the reciprocal of the period. Like if period equals, yeah. Okay, secant is the reciprocal of sine or cosine? Yep, cosine. Cosine of x. So each value of x, I'm just going to flip over. Okay, we did this before, so I'm not going to make us do it again. We have to set cosine equal to x to get our vertical asymptotes. So get vertical asymptotes. Cosine is 0 at pi halves, 3 pi halves, and it keeps going on forever. Then we're also at negative pi halves, and well, it just keeps going on and on forever in that direction as well. So we have a break of about pi each time. Okay, let's, oh, not that. Let's add our x and y axis. I'm going to do it right there and right there. Okay, we're only going to graph one period of it. So we're going to go from, yeah, well, because cosine is always going to be negative at the same point. So yes. For vertical isotopes, in this class, they will be, because we're not talking about the, like, you know, like H and K, shifting it left or right. They would change, we shift it left or right. But we're not talking about those in this class. Yep. Okay, we're only going to graph 2, I guess. Okay. We'll do 2, and we'll call it a day. Okay. Let's start with my table. We're doing x. We're doing secant of x. So big. Secant of x, which is the reciprocal of cosine. So over here, we are at negative pi halves, and this is just pi halves. So I want the values in the middle. This is the same thing as kind of before with tangent. So I'm finding my values in the middle, which we did the same thing for before. Okay. Secant at negative pi halves. We are on a vertical asymptote, so what is the value going to be there? Secant at negative pi halves, we would be about right here, which is a vertical asymptote. So at any vertical asymptote, my x value is what? Undefined. So undefined there, we are undefined here. Okay, this is when it gets a little tricky. Go to negative pi fourths. Negative pi fourths is the same as 7 pi fourths. I'm just going to go clockwise when I'm doing my unit circle. So, Declan, if I'm at 7 pi fourths, what is cosine at 7 pi fourths? You got it. Look on a unicircle.
What was the question?
What at 7 pi fourths, what is cosine? Cosine might,
Square root of 2?
yeah, 2 square root of 2?
No, square root of 2.
Okay. Square root of 2 over 2. And because it's a reciprocal of cosine, we're putting that under 1. Okay. Now we need to simplify this fraction. How do I simplify this fraction? Keep, change, flip. Yep, so I keep 1, I change multiplication, and then I flip my fraction. So I have 2 over square root of 2. 1 times anything is just itself. So I have 2 square root of 2. And then, Benj, I don't like radicals in my denominator, right? How do I get rid of them? Yep. Multiplied by clever choice of 1. And I'm left with 2. I'm simplifying the fraction. Because we can't, we need to, because we can't have radicals in the denominator. Yep. So, Kian, what does this come out to? So it's 2 square root of 2, and my denominator would just be 2. Yeah? Do we have questions? Okay. What happens to my 2 outside 2's? Yep, so they simplify and I have a square root of 2. Okay. Guess what? At pi fourths, we have the same thing, right? 1 over square root of 2 over 2. Yes, so it's still going to be square root of 2. Okay, we got at 0. I'm just going to put an arrow there. I should make this bigger next time. Okay, at 0, what is cosine? 1. So I have 1 over 1. 1 over 1 is just 1. Okay. So my values right now are undefined, square root of 2, 1, square root of 2, and undefined right now.
This is all negative for pi points. All of the points.
No. This is each point. I'm just shifting it over so we can see it.
Doesn't one of them have to be negative?
One of them's not negative.
The top one says a negative, though. You have a negative sign in front of that one. Oh, that's an equals.
Equal. Yep. Okay, let's graph it. Negative pi halves, we are undefined. Yeah? Okay. Shift over. Then I'm at negative pi fourths right there. And I'm going up about grad 2. So right about there. It says above 1. It's a bit above 1. What? Going up a square root of 2. So the square root of 2 is like, let's look it up. I think it's too cloudy for the sun to like reflect it and make it. This as a decimal is about 1.4 something. So a little bit above. Okay. I got my 2 points. I got 1 point. Second point is at 0, 1. So I'm at 0, 0. Go up 1. I got another point right there, which is pi fourths, rad 2.
What's this one supposed to look like?
I don't know. Can I draw the points? What do you get? Yeah. Did you say that or did Jade say that? Yep. So it's a parabola going like this. Up. As such. Okay. We're going to pause for a second. What? Oh. We're going to pause for a second. I'm going to graph cosine on this for a second, okay? Cosine looks like this. Ooh, that was bad. Wait. In purple, I'm going to graph cosine. Okay, it goes like this, and it keeps going on and on forever. And if I go in this direction, going like this, and we're going on. Okay, what point at cosine did I keep in this one right here? 1, 0, right? Okay, I'm going to keep that same point down here in the negative direction. All I'm doing is taking this shape right here, Declan, I'm going to flip it over, and then it makes my parabola. Okay, so this point flips to right here, because we're doing the reciprocal. This one flips to right here. So then I have another one, and it looks like this. Okay, do you think the next one is going to be open upwards or open downwards if I graph it up here? Upwards. So I'm here, here, here. Boom, 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 boom. What about over here? What should this one look like? Bench, what is this one looking like? Yep, okay, open downwards, like so. Because it keeps going on forever. All of these functions go on and on and on and on forever, because I can keep going around my circle on and on and on forever. Yeah. So if I go back 2 Desmos for a second, and I change this to secant, it looks like this. And it goes on and on and on and on forever. If I change A, changing it this way. If I change B, we're shrinking it, and then we're expanding, expanding, expanding. What? Yeah, A. Goes up, kind of down, then it flips. Boom. Like that. Okay. That is... I'm going to scooch out for a second. I can't scooch out. Okay. That is secant. Wasn't it fun?
That's the right words I would use, but sure.
Okay. We have one more. And we have 3 minutes. Guess what? We can do it in 3 minutes. We have 5 minutes. About. We can do this one. You see how we just flipped it before? We're going to flip it. The next one, I'm not even going to do a table because I'm very sick of tables, and I think we all are. Y equals cosecant of x, which is 1 over what? What is it the reciprocal of? Wenzel, what is it the reciprocal of? What is cosecant the reciprocal of? Yeah. What goes on the bottom here? What goes on the bottom? Okay, I'll give you a hint. Up above, we had the reciprocal of cosine. We already did the reciprocal of tangent. What's left? Cosecant, what's the reciprocal function? Yeah, what is it? Sine. So we're doing it 1 over sine. Sine has vertical asymptotes. We said this before. Where is its vertical asymptotes? All of the reciprocal functions and tangent have vertical asymptotes, yes. No. No. Look back at the videos when we graph them. No vertical asymptotes, yes. When was sine negative? We did this one in tangent. Oh wait, at pi. Yep, where else? 2 pi. Also at 0 and negative pi. And it keeps going on and on forever in both directions. Okay, we're not even gonna make a table. We're just gonna look at it. Okay, let's put our vertical asymptotes. Boom, boom, boom. Down, up, down, up. Vertical asymptotes. This will be pi. Declan, what's my next one? If I go in this direction. Yep, 2 pi. What if I go in the negative direction? Yep. Can you graph the sine function on this graph? graph it. Graph sine here. What does sine look like? Okay, where do I start for sine? 0. Then do I go up? Yeah? So I go right there. Where's my next point? Yep. Go down. I go up. This is sine. This is not cosecant, but we're going to use it. Just like before, we flipped it because it's the reciprocal. So if I flip it, what shape is going to go up here? Yep, it's a U flipped upwards. What about down here? How does it change? What? Oh wait, I would. Oh wait, kind of like an N. Sure. It's flipped downwards. Beatrice, what about up here? What is it going to look like? Yes. Flipped upwards. That's my phone. Okay. Lucy, what about down here? What is it going to look like?
Downwards.
What's so funny? Okay. I mean, that's it. That was the end of the lesson. You guys start laughing at the end of the lesson. Okay. Domain. Okay. We'll talk about that tomorrow. You have homework. Yep, homework. Homework. 7.5. Page. Yes. 385. You can do 4, 5, 10, 12, 15, and 17. That's it. 1, 2, 3, 4, 5, 6. 6 problems. Yeah. Okay. Domain and range of this guy. This domain, oh, I already wrote it, is all real numbers except every other pi. So we just call that not equal to n pi's. So I could have 1 pi, 2 pi, 3 pi. That's where we have our asymptotes. Yep. X does not equal n pi's. So every single pi, we have a vertical asymptote. We'll talk about the range tomorrow.